paper. Can I send it to you?
Yeah, your volume is a bit low.
Okay, sir. So now I'm audible?
Yeah.
Ah.
How was the maths exam?
It was easy, sir.
How much are you getting?
I'm getting around 90 or 90 plus.
Okay, where did you leave the marks?
Actually, I left a mark in 1 mark, sir.
What is the reason?
It was a creative question, so I strongly used the term, sir.
Okay. Assertion reason.
No, sir.
Okay. How many 1 mark?
In 14, I'm just getting as 13, sir.
Okay.
2 marks was easy, all from book back, and 5 marks also from book back, sir.
Okay. When is the science
Majority,
exam?
yes, sir.
When is the science exam?
On 30th, sir.
Monday.
Yes, sir.
Okay. Tomorrow I won't be here.
Okay.
But today or two. Fine.
Okay. Sir, can you reteach me that rocket proportionals answer from physics, sir?
From the book.
From the book.
Which page number?
1 second.
Tell the page number.
Page number 8, sir.
8.
8.
They have not mentioned much. Okay, it's basically with the rocket.
Hmm. Should we draw the diagram for rocket proportional, sir?
Not there in the book. They will not ask much. Not
Okay.
much is described here. Basically,
Hmm.
this rocket will have some fuel, right?
Hmm. Hmm.
So the fuel will burn and come out. So some mass will come out. When this thing
Hmm.
comes out, the initial mass, if it is capital M, which is the rocket mass plus the fuel,
Hmm.
due to minus M.
Yeah.
Okay, so initially, the whole thing M
Hmm.
is moving at with the velocity say u. After that, this M minus M will move with the velocity, should be move with the upward velocity say u1, and this M
Hmm.
will move down with the velocity we have say u fuel. So obviously
Okay.
u1 will be greater than this u. That you can check because initial momentum is upwards, which is m into u. Final momentum, upward momentum is m minus m into u1, and
Hmm.
then minus mu because uf is downwards. So muf is downwards. So that's why this negative sign is there. Because I have to take
Okay.
the total upward momentum Or you can say the upward momentum is positive. So initially it's U is up. So the full momentum is upwards. Final momentum U1 is up of this mass M minus M because M must come out as burnt fuel.
Yes,
So
sir.
I can conclude that U1. So M minus M into U plus M by capital M minus small m into U is U1. Take this negative term here and they divide out by this one. Okay, so this should be more than. I made some mistake.
Okay. Sir, I just need this answer in equation. Can you send me that also?
Wait.
Okay, sir.
So I have to say UF is more than this one. Sorry, not UF, U1. So what it is correct only. MU1. So U1, I have to take this thing here, MUF. Okay. So I'm just divided by. So this is actually greater than 1. Because denominator is small, right? Right now? Yes or no?
Yes, sir.
So obviously U1 is greater than U because this is a positive quantity. Because UF is the magnitude and the direction I've taken separately. And this is a positive quantity. So this is a positive quantity and this thing is greater than 1. So U1 is greater than U.
1.
So
Okay.
speed is increasing from U to U1 because some momentum is coming downwards.
Okay.
So that is
As
the
those fluids.
Just a minute. Let me read what they've done. Propulsion is based on the conservation of momentum. Rockets are filled with fuel. Okay, in proper time. When the rocket is fired, this burnt fuel is burnt, and hot gas is ejected with high speed, producing huge momentum in the downward direction. To balance this momentum, you can opposite reaction is produced in the compression chamber, projecting rocket forward. Okay, this it's like Newton's third law. If you push two objects, if one object is getting pushed leftwards, the other object should get pushed rightwards. So the fuel is getting pushed downwards, so the rocket should get pushed upwards.
Okay.
While in motion, the mass of the rocket gradually decreases until the fuel is completely burnt out. So there's no external force acting on the amount of the system is conserved. The mass of the rocket decreases little with altitude, which results in gradual increase in the velocity of the rocket at one stage, which is velocity sufficient to escape the reaction to the world. Escape velocity. Okay. Yeah, this is the basic idea. Okay, there are two ways you can explain this. One is Newton's third law. If there are two objects, okay, one thing is getting pushed this way, there will be a reaction, right?
Yes, sir.
Okay, so this fuel is getting pushed this way, downwards.
Yes, sir.
The rocket will get pushed the opposite way, that's upwards.
So as
continuously the fuel is getting pushed.
Yes, sir.
Once some fuel is burned and coming out, next set of fuel is coming out. Okay, so it will be continuous the reaction force in the upward direction, which will keep pushing the rocket upwards. That's one way to explain. Another is conservation of momentum. Okay, initially the momentum is M into U. After that, some momentum is downwards. So the upward momentum should be low. So that the sum is the previous momentum. This is initial some upward momentum. That's equal to some upward momentum plus some downward momentum. But the downward momentum will subtract, right?
Yes,
upward
sir.
momentum should be this initial momentum plus a positive quantity. That should increase the momentum, and again the mass is decreased.
Okay.
So momentum is increasing and also the mass is decreasing. That means the velocity should
Hmm.
increase.
Hmm.
Even for same momentum, if mass is decreasing, mean velocity has to increase to
Hmm.
keep the momentum same. But here the momentum is
Hmm.
increasing and also the mass is decreasing. That means
Yes,
velocity has
sir.
to increase still further.
Hmm.
So
Okay.
this is the understanding you have to
Hmm.
explain. Either you write in your own notes or just read what is in the book. You
Hmm.
have to write it.
Okay, sir.
Next,
Next is
you send something. Okay.
uh,
This is model paper.
yes, sir.
Describe rocket propulsion.
Hmm.
This is the same thing.
Yes, sir.
How the rocket is picking up speed because the fuel
Hmm.
is being pushed down.
Hmm.
There will be a reaction which is pushing upwards. That is one way.
Yes, sir.
Another way is conservation of
Hmm.
momentum. Okay.
Hmm.
Two ways you have to
Hmm.
explain.
Okay, sir.
It is 1 mark, I have 4 marks. No, so obviously,
4 marks, sir.
yeah, so you have to explain both.
Hmm.
Use a simple
So
microscope.
then,
This microscope means you can see small things.
yes, sir. And we can read those small letters, and is used
That is
for
just a,
repairing what
okay,
is.
simple. Okay, fine. Whatever is given in the book, you
Okay.
write it.
Okay, sir.
Application of simple microscope.
Hmm.
Ultrasonic waves. What does it mean?
It means above 20 hertz.
No, you have to, he's asking term, no? So you have to split this into
Hmm.
two, ultra and then
Yes,
sonic.
sir.
What does sonic mean?
Hmm. Sonic means the sound, sir.
Sound. That's true.
Hmm.
Ultra means what?
More than 20 hertz.
Ultra means higher.
Higher. Okay.
Infra means less.
Hmm.
Okay. So ultrasonic
Okay.
means higher frequency. Then
Okay, sir.
sonic means human ear can hear only up to a certain
Okay.
frequency range.
Hmm.
The frequency above that maximum frequency you can hear is ultrasonic.
Hmm. Okay, sir.
Okay. What is the range of human ear that you should know approximately?
Uh, Approximately 20 hertz, sir.
No, no, range. There's a
Range
range.
is between 20 hertz to 20,000 hertz, sir.
So that is 20,000 is 20K.
Yes, sir.
So ultra means greater than 20K.
Yes, sir. So the examples would be mosquitoes and dogs,
Yeah.
dolphins, all come, sir.
So obviously less than 20 is infra. Infra means less, ultra means
Mm,
higher. Okay.
mm,
So greater than 20K, it's ultra. Okay.
okay.
Sonic is the range where human beings can hear audible rays. So 20 to 20,000. Remember as K, that will be simple. 20 hertz to
Okay, sir.
20K. Okay, where K is
Mm,
1000. So greater than 20K is ultrasonic.
ultrasonic waves.
So even less than 20 hertz you cannot hear.
Mm,
Okay. So what is the use of this? So ultrasonic, this thing
Stethoscope.
is mm,
Stethoscope, sir.
no, even for scanning, right?
Uh, Actually,
You can see what
sir,
is in.
scanning comes for the comes for nuclear physics, sir.
Yeah, but ultrasound
Ah,
here also they will mention because this is
mm,
harmless, right? Compared to
mm,
X-ray,
okay.
but I don't know where they mention.
Mm,
In medical applications of echo, it's basically ultrasonic, right?
yes, sir.
Yeah. So to see the inside image. Another thing is compared to X-ray, what is the
Mm,
advantage of ultrasonic?
ultrasonic. It is less harmful, sir.
Yeah,
Mm,
X-rays are electromagnetic waves. Okay,
mm,
but the frequency is in the range where it will produce harm to the
mm,
human being. So that's why you should not use
okay.
unnecessarily. But compared to
Mm,
body X-rays, ultrasonic is just a sound wave.
mm,
So the harmful effects is less.
yes, sir.
Age of fossils is its
Age of fossil for and comes in biology, sir.
radioactivity, no?
It's also radioactivity. It also comes in chemistry and biology.
Hmm. Mention two
It
cases in
depends
the
on the how the
no
question
Doppler
is.
effect of in sound.
When the source and listener are at the same rest pointer, and then when the listener and the source moving in a such a way that the distance between them remain constant.
So one
When the
possibility is both are
source,
at rest.
uh,
Observer, sorry,
listener and the source.
source and listener both are rest.
Yes, sir.
Okay. Another possibility is both are moving the same velocity.
Mm.
That also the distance is not changing, no, between these two.
Yes, sir. It's constant.
Yeah. So Doppler effect means if the distance is shortening, the frequency will increase. If the distance is increasing, means frequency will decrease. But the difference is maintained because of both
Mm.
moving. Then also there is no Doppler effect.
Mm.
So these are the two
So
cases.
are they inversely proportional, sir?
No, it just depends on the distance. If it's not
Okay.
decreasing or changing with time, then the
Mm.
frequency will not change.
Mm.
Okay, so you can move either this way or it can also move either both
Mm.
towards it. Basically, same
Mm.
velocity.
Okay.
Velocity is nothing but speed with the direction.
Yes, sir.
Coefficient of real expansion. Basically, how to, I don't know how you remember, this increase in volume is proportional to
Mm.
the original volume and also
Or
proportional to the temperature rise. Okay,
okay.
so these two can combine and write as delta V equal to some constant. It's gamma, coefficient of
Mm.
real into V into
Mm.
delta T.
Okay.
Okay,
And
so if I make
note of
so if I
one
make if
second,
I take
sir.
unit volume, say 1 meter cube,
Mm.
and say a temperature of 1 degree Celsius, then gamma will be
Mm.
seen as delta V. So
Okay.
you're increasing the volume of 1 meter cube of the substance when the
Mm.
temperature is increased by 1 degree Celsius is
Mm.
coefficient of rate expansion.
Okay.
And the unit is this unit will cancel. It's per
Mm.
degree
Mm.
Celsius.
Okay.
because gamma is delta V by V, so the units will cancel, and then 1 by delta T, which is this one. Gears is there in physics, is it?
No, sir.
Okay.
I think it's from computer science.
Computer science.
Yes, sir. We have one lesson from computer science.
Gear is basically you have two rotating objects, a connected by a chain. Is it the one?
Okay. I haven't seen the computer science part, sir.
Oh, okay. See, basically this chain is moving, right? So the amount of movement of chain is same everywhere. So if it moves by L, or you can say this is small r, this is capital R. When this thing rotates 1, 2 pi r, this thing will rotate by the same amount. So the angle made by this thing, angle rotated by this one, say theta 1, angle rotated by this second one, theta for the same L is theta 1 will be L by r, because angle is the arc length by the radius.
Okay.
This L movement will happen along the circumference, right? So this theta 1
Yes,
will
sir.
be, and this theta 2 will be same L, because the same belt, same distance will be L by r. Okay, so obviously theta 2 will be less. So
Okay.
theta 2 or theta 1 is more, right? So theta 1 by theta 2 is r by r. Okay, so when this thing makes one rotation, this thing will make n1 will be this factor r by r times. When this thing rotates 1, this will rotate a lot of times. Suppose this thing is say circumference, say 5 meters, this say 1 meter, circumference 2 pi r. Okay, so the ratio, radius also in the ratio 5:1. So when this thing rotates once, this thing will rotate 5 times.
Okay, sir.
This is basically a gear.
Yes, sir.
That's what is happening in cycle, no? Cycle pedal will be so you will be rotating this one, and this is the back wheel. So when you rotate this thing once, you will rotate n number of times. That n is the ratio of the area.
Okay.
This is a simple question. You know, right?
Yes, sir.
What
Should
is
I
power?
equate it?
What is power dissipated?
Power equal to
Multiply, you can write in different ways. One is V into I, that's equal to I square R, because V is I into R, which can also be as V square by R. So what is given here is R is given, I is given. So we have to use this one. Okay, this is power. And the heat is, how is it related to power? What is the relation? Power into?
Power into V.
Power into?
Velocity.
No, time.
Okay.
Power is energy dissipated per unit second, no? Or rate of
Yes,
dissipation of energy. Rate means in how much time? I mean per time, per unit time. So power into time is the total energy. So this will be I square R into T. T is given as 5 minutes. So we convert to SI units. So 6 square 36
into
R,
5
and then 5 minutes into
and
60
3.
seconds.
Okay. So then the answer would be 0, 0, 18,
See,
and
one thing you can
88.
do this, you can write as 10 by 2, 10 by 2. Okay.
Mm,
So it will become 100 by 4.
mm,
And this 4 will go 9 times.
mm.
And then 60. So 9 6 are 54. So 54K. Instead of
Okay.
1000, you write as K. You will make
Okay.
reduce mistakes.
Mm.
So don't multiply 5 and all. 5 is 10 by 2.
Okay. 5 is 10 by
Okay.
2.
So 1 2 will cancel here. Another 2 will cancel here.
Okay.
Okay. So it will become 100. If you multiply by 5, then you're doing the wrong way.
Okay.
It will take time. And also mistakes will
Mm.
happen.
Okay, sir.
Even 25 you should write as 100 by 4.
100 by 4. Okay.
If it doesn't cancel, then it's not useful. Still, 10 multiplying is easy.
Mm.
Avogadro number is, this you should know.
Yes, sir. It's 6.23 into 10 to the power 23.
Hmm.
Option C.
If it's a large number, so obviously these two are wrong, not
Yes,
minus.
sir.
It is place, and you notice 10 to 23, 6.02.
Mm. Mm. There's another question from physics, sir. Mm.
Graysphobia.
Bifocal lens, sir.
So 3 defects are there. First is Mayo, right?
Myo, hypermetropia,
Ah.
and
Third one is
pyrotropia,
Chris. This is the
and
third
we
one, right?
have another one also, sir. Something that starts from A.
Astigmatism.
Yes, sir.
Okay, so that's how I remember. This is the first one. Second one, the third one. This is a student problem. This is the old
Mm.
age problem.
And the old
This
age
is
problem
combination.
combination. Actually, it's combination of hypermetropia.
No, these two both will be there. No, this myopia. So
Mm.
this biconvex lens, no bifocal lens.
Yes, sir.
It's searching so slowly.
It's page number 25, sir.
What they are given bifocal.
Mm. Below that, sir.
Yeah.
Ah.
It's coming. Okay, this is how I remember. First defect is myopia. Okay, this is student problem. Second one is this old age, this one hypermetropia, where you cannot read the books, short, small letters.
Mm.
Okay, and this is the combination.
Mm.
Both defects.
Mm.
Okay, so this is bifocal. This one.
Mm.
Astigmatism is, yeah.
Cylindrical
Astigmatism is,
lens.
it's a distortion problem.
Mm.
See, something as a square or rectangle should appear as rectangle for normal person, but it will get
Mm.
distorted.
Okay.
Okay, that you should correct using cylindrical lens.
Okay.
Normal lens is spherical lens. You have two spheres intersecting, and you take this intersecting part. Okay, similarly, I can take two cylinders
Okay.
and make them intersect. Okay, and this intersecting part, that will be the lens, cylindrical lens.
Mm.
Okay,
Okay, sir.
so normal lens is spherical lens formed by
Okay.
intersecting two spheres. This cylindrical lens means instead of sphere, you have to use cylinder.
Mm.
and
Mm.
take the intersecting part for convex cylindrical lens.
Okay.
Explain our domestic electric circuits. How many marks?
7 marks. So,
3, no? No, how
7 marks
many marks?
question, sir.
7
7
marks.
mark.
Wow.
Yes, sir.
One thing about domestic is what is this? What is the first point
Those
about
are
domestic?
those are series connectors.
No,
Okay, 1 sec.
parallel. See, if you have, say, fan, okay,
Okay.
and then say light,
Mm.
okay, all this thing, there will be a positive voltage, say plus
Mm.
230, and there will be zero
Mm.
voltage. So everything
Mm.
will be connected between 0 and 230.
So everything will be connected in a main box.
No, from the main, there will be 2 wires. One is
Okay.
230 volts, one is 0
It
volt.
supplies the power. It supplies the power.
Now, so
Okay.
everything will be connected in parallel.
Mm.
This is the first point.
It's
And so
parallel.
what will getting added up is the current. Suppose this fan is taking say
Mm.
I1, and this light is getting I2, and this fridge is taking say I3.
Mm.
So total current coming
Mm.
from this mains will be
Mm.
I1 plus I2 plus I3,
Mm.
so on. Okay. But this
Okay.
there will be heating of this wire, right? Through which the current is
Yes,
coming.
sir.
So that will be I
Mm.
square R. R the value is
Mm.
fixed of that wire. So if
Mm.
this I is beyond a limit, this
Mm.
wire will get heated up too much. So
Mm.
it will melt. So to prevent that, we have a fuse here,
Mm.
which will melt first before the wire melts. So the melting point of fuse
Mm.
should be less than melting point of the wire.
Mm.
Okay. In that case, this fuse will melt, and then I can uh, reduce this load, and I'll change the fuse wire, and I'll connect it again. Suppose this wire melts means it's difficult to repair and also costly.
Mm.
Okay.
Mm.
Fuse will just have to open this fuse, remove the wire, and put it. Nowadays, instead of fuse, you have tripper. It's like a switch.
Triple.
Okay. So when this current becomes high, automatically the switch will fall down.
Mm.
Okay.
Okay.
So again, I have to make sure the load is reduced, and then I have to put the switch back.
Mm.
So this is the important thing about domestic. First important point is parallel connection. Okay.
Okay.
Second thing too, there is a
Mm.
protection which is either fuse or whatever, I don't know what term they used here.
Okay.
Switch
They
gear
use the fuse wire, sir.
or
Fuse wire
fuse
and
wire is there, and also there is a
uh
tripping switch, right?
uh
That
yes,
is there.
yes, sir. Yes, sir. They have mentioned this as MCB.
Um, what is MCB full form? Miniature circuit breaker. It's like a switch. Miniature
Yes,
means
sir.
small.
Mm.
Okay. Circuit breaker means there will be big ones used in the industry.
Mm.
Okay. Miniature means it's for home use. So MCB, so
Okay.
this thing will, the switch will drop down or it will turn off. You just have to make
Mm.
sure the load is reduced and then you have to put the switch up.
Okay.
So this is the diagram. There will be two wires. One
Mm.
is the live wire, which is 230 volts or 220. This is 10.
Mm.
So between these two wires, there will be connection of potential difference of 230 volts. So all the devices, 1, 2, 3, one could be fan, one could be fridge, one could be AC. Yeah, all these things are connected to, all the things are connected to these two wires. And it's also better to see potential difference is 230. So I can also have 500 here, and then 500 plus 230, 730 here. Then also I can get a difference of 230 volts. But it is safe to make this thing as 0. Okay, so to make this thing 0, connect it to 0. Touch the 0 point. That way this will become 0 and 230. Because when you get a shock, when the person is getting a shock, he'll touch this wire and his leg will be in the ground, which is at 0 volt. So suppose if it is 730, the potential difference is 730 will be across the person. So it'll get more damage. But suppose it's just 230, then will be lesser damage. Okay, let's say it has to be earth. So for the lower potential terminal should be earth to 0 volts.
Okay.
So another important point is earthing. To reduce the amount of shock. You can draw this figure with the earth wiring.
Okay.
And the protection. Here the switch which will drop down. The normal position is upwards.
Okay.
$220. So usually the wire will have a rating of 5 amps. And there will be another thicker wire which can handle 15 amps. So all fridge and AC will connected to this 15 amps wire, thick wire.
Okay.
Okay, like AC, fridge,
Yes, sir.
electric iron, heaters. Even in the switch box, you have 2 sockets. One is a big socket, one is a small socket. The big socket is the 15 amps socket, which can handle a load of 15 amps safely. Smaller socket is a 5 amp socket. And another advantage of parallel connection is one of the thing is broken. Say this device has gone bad.
And the other circuit would not be get disturbed.
They will still be connected.
Yes, sir.
So 4 or 5 points are there.
So how many points should I write for 7 marks, sir, as a paragraph or a point?
Paragraph with points. Paragraph, the point should be visible. Because when they're checking the paper, they see the points.
Okay.
Either you write in terms of paragraph or in terms of point does not matter. Even in a sentence, the point has to be there.
Okay.
With certain things here, you can write as point also, but sometimes it won't look good if you write as a point.
Okay.
Where you're explaining continuously. There you just have to underline whatever you think is a point. That'll be easy for correcting also.
Okay.
So they will feel comfortable giving more marks. Compare powders alpha, beta, and gamma radiations.
Yes, sir.
One basic question which is not in the book. Why is it called alpha, beta, gamma?
Sir, it is there in the book, sir.
What is the reason?
No, sir. They're like splitting into 3 parts, and they'll give you some topics about it, like
No, that is fine.
particles.
What I'm saying is, why is it called alpha? Why not phi? Why not delta? Alpha, beta, gamma is ABC in Greek alphabets.
Yes, sir.
Okay, so when you have some unknowns in maths, we are either represented as ABC, right? Variables.
Yes, sir.
But also X for unknown variable. So these radiations, when they first detected, they were not known what it is. So they had to give an arbitrary name, right? So they gave ABC,
Yes, sir.
which in Greek thing is alpha, beta, gamma.
Okay, sir.
And this alpha is nothing but helium nucleus.
Yeah.
Charge is 2, mass is 4. So that
And beta is electron basis.
No, just electron.
Yeah, electron base.
Gamma is electromagnetic wave, like light, but frequency will be higher.